histogram. The purpose of this activity is to construct a frequency distribution and then a relative frequency distribution. We then use it to draw a histogram and to describe the histogram using the shape, the center, and the spread. When constructing a histogram manually by hand, we need to know what the width of each of the class is. We were asked to use the width of 10 starting with 5. The following data represent annual franchise fees in thousands of dollars for a random sample of 36 pizza franchises. Each of these numbers represent the dollars amount in thousands of dollars for the annual franchise fees. For example, the number 25 represents one pizza franchise that pays $25,000 annually for the fee. The distribution table consists of two columns. The columns on the left is the category called the classes, and the column on the right hand side is the frequency or the count. We were told to start with a class of 5 with the width of 10. That means starting at 5 and we add 10 to it, and so the first class start at 5 and it goes all the way to 15. Notice that 15 minus 5 is 10. The notation that we use is open the brackets and close the parentheses. This notation means any number starting at 5 all the way up to 15, but not including 15, will be in this first class. The next class will pick up where the first class left off. So the next class is therefore 15. The width must be the same. And the width is 10, so we add 10 to this to get 25. Open bracket, close parentheses. The next width is therefore 25, add 10 to it, 35. And the next class is 35 all the way to 45. And 45 all the way to 55. And then 55 to 65. And then 65 to 75, and then 75 to 85, and then 85 to 95, and so on. Before we construct the table, we might first examine the data to see which one is the minimum and which number is the maximum. That means that we're going to go through the list to see what the smallest number is and what the largest number is. In this case, it seems that the smallest number is 5.5 and the largest number is 89. What that means is that we don't have to add another class after 89 because 89 would be in the last class already. Now, the count would list the count, or it is a number that tells us how many of these data is in the first class, in the second class. For example, to keep track of how many, we usually use the tick mark at first. So for example, we're going to go through the list 25, 15, 14.5. 25 would fall into the third class. Remember the notation with the open bracket, that means we want to include number 25. And with the closed parentheses, that means that we want to include numbers that is up to 35, but not including 35. If it is 35, we want to go to the next class. Thus, 15 is in the second class, 14.5 is in the first class, 22.1 is in the second class, 15.5 is in the second class, 30 is in the third class. Notice that there are 1, 2, 3, 4, 5, 6 numbers in the first row. There are 6 tick marks for those 6 numbers. We then move on to the second row. 15.5 is in between 15 and 25. 5.5, first class. 29, third class. 89, last class. 25.5 is between 25 and 35. 21 is between 15 and 25. Now, if it's the fifth one, then we would just simply cross this out, knowing that that is a block of 5. Next, 7.5 is between 5 to 15. 15.2 is between 15 to 25. 22.5 is in the second class. 17.5, second class. 12.5 in the first class. And 35.5 in between 35 and 45. And we keep doing this until we get to the last number in the data set. Alright, we're done. The last number is 20, which is between 15 and 25. The number 35 is in the class 35 to 45. Now, if we keep track of this, there are 10 in the first class, there are 15 in the second class, there are 7 in the third class, there are 3 in the fourth class, and there's 1 in the last class. If we add these up, 7 plus 3 is 10, 10 plus 10 is 20, plus 15 is 35, and 1 it is 36. So yes, there are 36 numbers. This is what we call the frequency distribution table. Note that most often time, you don't see the tick mark in the frequency table. These tick marks help us count how many in each class. Usually, this is what you see when we look at the frequency distribution. It tells us the category in the classes and the frequency, how many. Notice that we just simply copy this table down. To construct a relative frequency, we take the frequency divided by the total multiplied 100%. So the relative frequency is the frequency, which is the count, divided by the total or the sum and multiplied 100%. For example, for the first class, the frequency, the count is 10, the sum is 36. We then multiply 100%. 10 divided by 36 times 100% is 27.78%. Oftentimes, we want to report either 1 decimal percent or whole number percentage. So we're going to round it to 28%. For the second class, the relative frequency is therefore 15 divided by the total 36 times 100%. If we round it to whole percentage, this is 42%. 7 divided by 36 times 100% is 19%. We rounded it. 3 out of 36 is 8.33%, 8%. And 1 divided by 36 is 0.0277 times 100. And so this is 3%. Again, 1 divided by 36 times 100% is 0.0278 times 100%. So that is 2.78%, and we round it to 3%. Now, the total need to add up equal to 100%. So if we were to take 28 plus 42 plus 19 plus 8 plus 3, then we will get 100%. This is what we call a relative frequency table. To construct a histogram, we draw the axis. The horizontal axis will contain the classes, and the vertical axis will list either the frequency, which is the count, or the relative frequency, one or the other. The first class is from 5 to 15, so this is 5 to 15. The second class is 15 to 25. The next class is 25 to 35, 35 to 45, 45 to 55, 55 to 65, 65 to 75, 75 to 85, and so on. The maximum count is 15, and so I will scale this as 5, 10, 15. The first class had 10 count in it, and so we're going to draw a rectangle for the bar. Notice that all of these bars have the same width. The first bar go all the way to 10 for 10 counts. The second class go all the way to 15. So we draw a rectangle or a bar with the same width all the way to 15, indicating that there are 15 counts in this second class. The next class has 7 count. Between 5 and 10 is 7.5, so 7 is roughly there. Again, this bar had the same width, 7. The next class has 3 counts, so all the way up to 3, same width or roughly same width. Now the next class, 45 to 55, there's no count in it, so there's no bar, there's no height. 55 to 65, there's none, no height. 65 to 75, there's no height. 75 to 85, there's no height. But then from 85 to 95, there's 1, meaning that the bar gonna go up to 1 only. This is what we call a histogram. The histogram has no gap in between, as you can see. They will have gap in between if the height of the bar is 0. Next, we're going to describe this histogram. It has one peak. We call this unimode. And the tail on the right hand side is longer. And so we would say that this is skewed to the right. This is the shape of this histogram, skewed to the right. The center of the histogram is a number in the middle that would separate the distribution into 2 equals half. If we were to use 45, then it wouldn't be fair because there is only 1 on the right hand side of 45 and there are 35 on the left. And so the center is probably somewhere in the bar that has 15 counts. A number that is between 15 and 25, if we were to pick one number, then we would use the middle. The middle of 15 and 25 is 20, and so the center would be 20. Now the spread, there are many ways to describe the spread, but for now, the spread is from the minimum to the maximum. The minimum in the data is 5.5 and the maximum is 89. And so we would say that the spread is 5.5 to 89. If we don't have the data, we know that it is 5.5 is the minimum and 89 is the maximum from the data. But let's just say that if we don't have the data and we were given a histogram, then we must say that the minimum is 5 and the maximum is 95. Oftentimes, to use a number to represent the bar, we just use the middle of the class. The middle of 5 to 15 is therefore 10. The middle of 85 to 95 is 90. And so We can even say the spread is 10 to 90.